Welcome to EDU World Space.
For this problem, we're asked to do 4 different things. We need to calculate the point estimate of the mean, a 90% confidence interval, or as is abbreviated commonly CI, for the mean. We need to compare our results with the true mean, and we need to identify any outliers. And to do that, we're given 17 different ages of women representatives in state legislatures. So, let's get started. The very first thing I'm going to do is calculate the sample mean. Recall that in order to calculate the mean, you need to take the average of all our different numbers. So if you do it correctly, you should get 33.4. The next thing I'm going to do is calculate the standard deviation by using this formula right here. And you should get 28.7. So we have our mean, we have our standard deviation. Now we need to find our t-statistic. For our t-statistic, we need 2 different things. We need our degrees of freedom, and we need our confidence interval percentage. Our degrees of freedom is going to be n minus 1, or 17 minus 1, which is equal to 16. And we know our CI percent is 90, as given to us in the problem. So, using that, we can use our t-table at the back of the book, find degrees of freedom of 16, find the confidence interval column of 90, and it should intersect at a t-value of 1.746. Just going to write this in a different color so we can identify it later. Okay, so we have our 3 elements that we would need for a confidence interval. So let's write that out. Recall that the formula for a confidence interval is your x bar, or our sample mean, plus or minus t times s over the square root of n, where s is your sample standard deviation and n is the square root of the number of data sets in your sample. So let's sub things in. We know that our x bar was 33.4, which I believe I made blue. We are going to plus or minus our t-value, which is 1.746. Let me rewrite that. And we're going to multiply that by our standard deviation, which I made purple, and that was 28.7, all over the square root of 17. So I'll give you a moment to plug all that into your calculator. Be careful when you're doing this math right here. There's a lot of operations happening, and if you're not careful with your parentheses and your fractions, it's a very common area for algebra mistakes. So take your time, pause if needed, and try to get an answer. If you've done it correctly, your range should be 21.2 less than or equal to mu less than or equal to 45.6. And that is our confidence interval at 90% for the average age of a woman representative. Now let's take a moment to go back and see what we actually need to figure out. Our point estimate of the mean, we did that. That's 33.4. It's our sample mean based on these 17 ages. Our 90% confidence interval, we did that right here, 21 to about 45. That's basically the range we're talking about here. Now we need to compare our results. So we're told that the true mean is equal to 31.7, which is approximately 32 years old. Our mean of 33.4, or basically 33 years old, is not that far off from 32. Remember that this is a sample size of only 17 women. As our sample size increases to the entire population, we will keep getting closer to the true age of women representatives. We also see that our true mean of 32 is well within our calculated range. So we are confident that we're on the right track since our estimated range does encompass the true mean. The last thing we need to do is figure out any outliers, or data values that could affect our confidence interval one way or the other. So let's go back and look at our numbers. I see two pretty glaring outliers in this data set. Number one is this 5. Remember what these values mean. They're telling you how old a representative is in a state legislature. I really don't think that there's any legislator out there who's a 5-year-old girl. So that to me seems like an impractical value. I'm also drawn to this 132. That means there's a 132-year-old woman in one of these state legislators. And that again seems pretty impractical considering the average lifespan of a human being. So I would say that these two values are, widening our confidence interval, since 5 and 132 are really, really quite far from our true mean of 32.